here we are on part B of lesson 1114, our last one. Earlier, we learned about the difference between a secant and a tangent line. And here we have an example that's going to use both concepts. For the given function, y equals f of x equals x squared plus x, find the equation of a secant line through the point where x has the given value and b, the equation of the tangent line. All right, so we're going to do A first. We're going to find the secant line from the pairs of x equals 2 and x equals 5. So our first step is going to be go to the y equals and enter the function. And this is with our graph. If your instructor could spell, I would be so awesome. All right, so we're going to do that. Here I go. I get my calculator. I go to the y equals. On y1, I'm entering x, second row, second key, and then the squared key, which is the fifth one down. And then I'm going to add the plus x, which is what I have. Now I'm going to go zoom 6 for a standard window. And there's my parabola. And I want 2 and 5. So now I'm going to use the fixture. To find the ordered pairs. I'm going to go second trace for second trace key, because all the graph keys are underneath the window, which is calc. Second calc. And then I'm going to choose number 1. And the number 1 is value. And that means we have the x and we want the y. All right, so here we go on that. Okay, so I'm going to go second trace. And then, oh, it didn't hit the second. Second trace, there I am, value. And I'm going to enter the 2. And my value is 6. And now I'm going to do the 5. Second calc, value, and I'm going to enter the 5. And I get, it looks like 30. Yeah, it looks like 30. So that would be 25 and 5, 30. Very good. All right. So now, because I have the 2 points, now I can construct the line. Okay, I'm going to then find the slope of the 2 points. All right, so we know that is m equals y's of 2 minus the y's of 1 over the x of 2 minus the x of 1. And I'm just going to go horizontally. And that is going to give me, okay, the 30 minus the 6 over the 5 minus the 2. And that's going to give me, it looks like 24 over 3, and it gives me 8. My slope is 8. So now I'm going to construct the secant line. To construct the secant line, I'm going to use the formula y equals m parenthesis x minus an x of 1 plus a y sub 1. So I'm going to use that first one because they're small numbers. So let me, I'm going to use this guy right here. All right, so let me get started on that. I'm going to have y equals my 8 times x minus the 2 plus, and I get the 6. Do the distributive property. And we're going to get y equals 8x minus the 10. 8x minus the 10. So this is the secant line. Now let me go to the graph and show you. Okay, I'm going to go to the second line, and I'm going to enter 8 second row second key minus the 10 and graph it. All right, you can see that it cuts through it. So I'm going to go to the window, and I'm going to make that a -5. And I'm going to make x a 10, I think is okay, because our lines were 2 and 5. And then I'm going to, on the y minimum, go -5. And then I'm going to go higher. I'm going to go, let's just do 15. And now I'm going to graph it. This way, you can see that it does go through. And oh, I needed 30. Oh, sorry about that. I needed 30. Because, so I'm going to do 35 and a scale of 5. All right, here we go. So we can see the whole graph. Okay, now, I know it's hard to see, but here's 2 and 6, and here's 5 and 30. And we can see that by going second, calc, and we're going to choose number 5, intersect. And I'm going to go to where I think, and I'm looking for 2. Oops, got too far. Maybe one more. There we go. I'm going to say enter, enter, enter. And I get 2 and 6. I'm going to do it again. And this time I'm going to go to 5. As close as I can. There's 5. Enter, enter, enter. So I get the 30. 5 and 30. So the line goes into 2 points on the graph, through 2 points. All right. So now we did that one. So now we're going to do the second part, which is a tangent line. At the first value, when x has the first value. So we already know that's 2 and 6. So all we need is a derivative slope. So I know it's the limit as it approaches 0 of f of x plus h minus f of x over h. And we've gotten pretty good at doing the small math. And I'm going to have x plus h squared plus x plus h minus, and I'll have parentheses, x squared plus x, all divided by that h. So I'm going to have x squared plus 2xh plus h squared plus x plus h minus x squared, and let me put this down for minus x all over h. Now remember, everything that does not have an h kind of cancels out, right? And so we get rid of those. And we notice we have h's left. So we're going to factor out the h's. All right, so we're going to cancel the h's and we're going to take the limit. So now I'm putting 0 everywhere h is. So our derivative function is dy dx equals 2x plus 1. And we know that's the change. That's the slope, tangent slope. So now we're going to insert 2. Before we had 8 as a slope, but a tangent slope is an instantaneous rate of change at 0.26 on the function. So now what we're going to do is do the equation of the tangent. We have m equals 5, if I did the math right, and we have the 0.26. I'm going to substitute my slope, insert 2 for x and 6 for y. I'm going to do distributive property. So y equals 5x minus 4 is what I get. And now I'm going to insert it in my calculator and verify. I'm going to move it over here. I'm going to go to the third, and I'm going to put 5x minus 4. Okay, and I'm going to look at my graph, and I'm going to go to the point, second calc, value of 2. And okay, notice that on the y1, it's on the original function. On 2, it's in my secant line as well. And then I click again, and now I have my tangent line in black. So my tangent line, so it is correct. Is everybody comfortable with that? Everyone comfortable with that? All right. So now I'm going to stop right there because it's 13 minutes, and we'll start again after this compelling example. Thank you for listening.